So let us start with today's class. I have shared my screen. Hope everybody can able to see that. So till yesterday we were discussing about the table space management, under which we have seen commands on how to create the table space, how to add a data file or how to resize a data file, all those things. So let us go and see starting with conversion of some commands here. So as you can see on the screen, we have commands on how to convert a table space from a dictionary managed table space to locally managed table space. So yesterday we have discussed about the advantages of locally managed table space over dictionary managed table space and all those things. So usually from 9A onwards, because dictionary managed is having some disadvantages, we as a DBA need to prefer to use locally managed table space. But still, if you identify that in a database we have some dictionary managed table space, so in such case you can convert them to local. So or you have other option, the vice versa option, that is if you want to convert a locally managed table space to a dictionary managed table space, even in such case also you can go ahead and do that. And that is possible with the commands what you are seeing right now on the screen or whatever I have highlighted. So the first command is to convert to a local. So the command you are using is executing dbms underscore space underscore admin. So this dbms underscore space underscore admin is a package, and under that package we have a procedure called tablespace underscore migrate underscore to underscore local. So I hope you people know about that. Every package is a combination or a group of procedures. So under this dbms space admin package, this tablespace migrate to local is one of the procedure. And using this procedure, we are going to convert a table space from a from a dictionary managed one to locally managed one. And below you have another command which is to convert a locally managed table space to a dictionary managed table space. So I mean, why? Because we have seen already the advantages and all. So you may get it out like why we require to convert a locally managed table space to dictionary, because dictionary is having some disadvantages. Yes, we do have disadvantages with the dictionary managed table space, but in real time when we go for, there are certain applications which will support only the dictionary managed table space. Or I mean, if you convert those or if you have the table space as locally managed table space, maybe those applications might not work, because those applications are very old and written in very old language, like we have C, C++, or after that some COBOL. You might heard about these kind of languages, so COBOL, Pascal and all. So if some of the applications are written in such kind of languages which are very old, they might not support the latest features of Oracle database. So that's the reason we may still need to continue with the old features like maintaining the dictionary managed table space. So that is the reason Oracle gives the flexibility to convert both from local to dictionary or dictionary to local. So that is how we have the commands here. And when we have 9i, 10g or 11g databases, definitely we will go for locally managed table space. So you might not use these commands very frequently in real time. So that is about the conversion commands. Just above those commands, you have a option to rename the table space, and as it is mentioned in the brackets, it is available from only 10g and carry forwarding to 11g. So if you create a table space in 9i, it is not possible to rename the table space. So this option is only from 10g. Let us go and look into that. So first I am taking out how many table spaces are there in the database, and for that we are going to use this view. Okay. So we have a table space by the name myTBS. So what I am doing now is I am changing the name of this table space from myTBS to myData. So the moment you change the name of the table space, you can query and you can see now it is showing as myData. But the problem with this command is the underlying data file names. So we have already seen this view. So if you look at here, underlying data file names will not change. Only the table space name will change, but underlying data file name still will be maintained as myTBS and myTBS2. But definitely it will not look nice if the table space is having a different name and data files are having a different name. So for this also, Oracle has having a procedure in order to convert the file names. So if at all you want to change the file name, or if at all you want to relocate the file from one mount point to another mount point, then we have certain steps that to be followed. So those steps are already given in the class notes here under this heading. So we will follow these steps and we will see how we can rename these files. So the first option or the first step that we are going to do is we are going to make the table space offline. So when you are going to make the table space offline, definitely the end users or the users who are connecting to the database will not be able to access the data under this particular table space. Then at OS level you are going to rename the file. So instead of myTBS, so I am giving it as mydata01.dbf, and similarly I have two files, so I need to rename both the files. So we renamed the files at OS level successfully, but if you try to make the table space online, it will throw an error because still your control file is not yet updated. So one thing important you need to know is whatever you do at Oracle level, OS will not understand that, and whatever you do at OS level, Oracle will not understand that. That means here I renamed the data file using OS command, that is mv command. So because I use this OS command, Oracle will not know that the file name was changed from this name to this name. So that was the problem. Like the same way, if you do something at Oracle level or at this SQL level, then OS will not understand what exactly happened. So that's the reason, even though you change the file names at OS level, your control file will not get updated. So to make control file understand that my data file names got changed, you are going to use these commands. So you are going to say alter table space name, rename data file, and you need to provide your old name and then new name. And because we have two files, we need to give two things over here, or two times. So the moment you do that, then your control files will get updated, and you can say table space online. And after your table space is online, if you do that, you can see your data file names also change it to mydata01 and mydata02. So this is how you are going to change the file names for a particular table space. And then we have commands on how to rename a system data file, because the steps whatever we have seen is not applicable for system table space. For example, if you look at here, so let's say I have some name over here. I want to change the name or I want to change the location. So because I want to change the name or location, if I try to make system table space offline, see what Oracle is going to do. So if you try to make system table space offline, what Oracle is saying is you cannot make the system table space offline, and it is saying shut down if necessary. That means if you really require to make the system table space offline, the only option that is available for us is to make the database shutdown. And you know that when we do the database shutdown, obviously no users can able to connect, and nothing can be accessible. So that is the point over here. That is the reason whenever you want to relocate or rename a system data file, the steps are a little bit different. Like first you need to shut down the database, then at OS level you need to rename the file, then you need to use a command like startup mount to come to mount state. Then you need to use a command alter database rename file, and you need to provide your old name and then new name, and this command will update the control file with the latest name, and finally you are going to open the database. So for a system data file, this is the procedure that you are going to follow. And then we have commands on how to drop a table space. So dropping a table space is actually of three different ways or three different commands we have. The first one is drop table space name, which is a simple command, and the second one is drop table space name including contents. So that is one command, and the third one is drop table space name including contents and data files. Now what is the difference between these three commands? We can see here. So first command, drop table space name, you can see the description here, which says this command will remove the table space information from the base tables, but still the data files are going to exist at OS level. So what happens here is if you use this command, it is going to update your base tables saying that the table space is no more related to the database, but the problem is the data files will still exist at OS level. Means Oracle will not remove them automatically. Manually we need to remove them using rm command. And we have the next option, that is drop table space name including contents. Now the description says this command will remove the table space information from the base tables, and it also clears the data file. So in first case it is not going to do anything with the data files, but in the second case it is going to clear the data file. Now what exactly mean by clearing the data file? It is nothing but, as in the brackets it is mentioned, it is emptying the contents. So whatever the data file is having the data, that data will be cleared off, or that data will be removed. Now what is the advantage for that? If you have any data file which is cleared, you can make use of the data file at a later point of time. For example, let me show you here. So I am dropping the table space including contents option, but even after dropping this, if you look at OS level, the files are still available. So you can see both mydata01 and mydata02, both are available. Now the advantage for us is you can reuse these particular files. So how we can reuse, you can see it here. So I am creating one table space, let's say by the name, let's say data, and I can say data file name reuse. So I can map this particular data file to a particular table space. So like that I can create one more thing, let's say index, oops, sorry. Okay, so index cannot be used as the name because that is a reserved word. So let me take index, and you can see it was reused. So basically this is the advantage that we have with including contents option. So whenever you drop a table space with including contents option, those data files will become empty and you can reuse those files. So instead of creating, removing and all every time, you can better make or reuse of these files. So similar reuse commands reuse command you have it here. So how to reuse a data file? So that option is there. And finally, the last option is dropping a table space including contents and data files. And for this command, the advantage is this is going to remove the file even at OS level also. That means, for example, if I say drop table space data including contents and data files. So if I say that whatever the data file that I map to this particular table space, so now you can see even the data file is also gone. At OS level also the file is removed. So like that I am removing this one also. So you will be observing that you can see no such file or directory. So when you drop a table space with the option including contents and data files, then the data files will get removed from OS level automatically. So that is how we are going to drop the table space. So before we proceed for the next feature, so anybody is having any queries, please let me know. Okay, so let us move to the next concept, that is big file table space. Now normally, even though from Oracle side there is no limit on the data file size, at till what level or till what size I can have data file limit. So frankly there is no limit. I mean, you can have 100 GB of a data file, you can have 200 GB of data file. So from Oracle side there is no limit, but some operating systems are having some limitation. So for example, in Windows, if you take the maximum data file size you can create is 45 GB. Or if you take some Linux operating systems, the maximum size that you can go for is only 60 GB. So like that there are some restrictions at OS level. Now suppose if you have the restriction like you can have only maximum of 60 GB, and suppose your database size is somewhere around 10 terabytes or 20 terabytes, then how many data files could be there? So if you look at that calculation, so I'm just taking this sheet here. So for a 10 terabytes database, like that means 10 into 1000, so it will be 10,000 and 10,000 GB. So under this I can have only 60 GB data file. So if you take it, you will be having almost 166 data files will be there. So now, so for a 10 terabytes database, if you take the limitation of each data file as 60 GB, then you would be having 166 or 167 plus data files. That means managing this 100 plus data files will be definitely a risk, not a risky job but a tedious task. So to avoid this kind of what I can say complexity, Oracle has introduced a concept from 10G onwards, which we call it as big file tablespace. So the advantage of big file tablespace is, as the name is saying, you can create a tablespace and the file will be having a big size, and that is the reason it is called as big file. So how much size we can have in big file tablespace is, you can even have one data file till 4 terabyte size. So that means whatever the OS limitation that you have for 60 GB, even you can cross that and you can grow till the size that you can reach to 4 terabytes. Now when you have a one data file with 4 terabyte, for a 10 terabyte database hardly you require only 3 databytes. So that's the advantage that we have with big file tablespace. So let us go and see the points. So the first point says, for managing the data files in VLDB, which stands for very large database, Oracle has introduced this concept of big file tablespace. And big file tablespace data files can grow into terabytes based on the block size. So depends on the block size, they will grow into more and more size. For example, for a 8 KB standard block size, one single big file can grow till 4 terabytes of space. And big file table spaces should be created only when we have striping and mirroring implemented at storage level in real time. So this third point is very important. So there was a concept at storage level, at disk level, which we call it as striping and mirroring. So only if you have this concept of striping and mirroring implemented at storage level, then only you should go and create big file table spaces. For a normal hard disk, you should not create big file table space, and if you do so, then it is going to show you a negative impact. So instead of giving you a positive impact, it will go and give you the negative impact. That means all your queries will run slow, performance issues will occur, all these things will happen. Now what exactly mean by this striping and mirroring? We will be understanding about these two under a concept called ASM. So till that time you need to just wait for some time. So that is the option. And point number 4 says, we can't add another data file to a big file table space until the first one reaches its maximum value. So that means if you have created a table space or big file table space with a data file, until unless that data file reaches 4 terabyte size, you cannot add one more data file. And the last and final option says, big file table spaces can be created only as locally managed table space, and that too with automatic segment space management. So shortly, automatic segment space management is called as ASSM. And just a while ago, we have seen commands on how to convert local to dictionary and dictionary to local. Just like that, sometimes you may require to convert manual segment space management to auto and automatic segment space management to manual. And if you require, or if you do that, or if you want to do that, then it is not possible. That is what this note says. Either in locally managed table space, shortly we call it as LMT, or dictionary managed table space, DMT. ASSM, that means automatic segment space management, once defined cannot be changed. So there is no option in Oracle on changing this particular feature. And below you have command on how to create a big file table space. So the command will be very simple. So you need to just add the keyword big file, and you need to provide the location. So you can see big file table space got created. So now initially I have given the size as 50 MB. So this 50 MB can increase till 4 terabytes. If you keep it in on auto extend mode and all, it can keep on increasing. Suppose if I try to add a data file to this big file table space, see what it will do. So you can see here, if I try to add a data file to big file table space, it clearly says that you cannot add a file to the big file table space until the first one reaches the maximum value. So basically this big file table space concept is going to help you whenever your database size is very huge. So that was the concept of big file table space. Then we have something called capacity planning. So capacity planning is actually not an Oracle DBA related concept, but it is more of a real-time concept. So basically in capacity planning, what we are going to do is, you are going to estimate how much hard disk space I may be requiring for my database in future. Or let me put in simple words to say that how much space I would be requiring for my database from the hard disk in the next coming 3 months, or in the next coming month, or something like that. So basically you are going to take an estimation from the values whatever we have, or whatever the historical data that we have. Now why this estimation or prior estimation is required, or why we require to estimate how much hard disk space we may require in the next coming 3 months and all. So usually what happens in real time is, if you want to get a hard disk, or if you want to get some hardware component, it is not only hard disk, let's say any hardware component, then it is not so easy to get it, because so much of process is involved. Suppose you want to get a hard disk, first of all you need to send out an email to Unix team, and the Unix team should confirm that the requirement is fine. Then Unix team they are going to send their approval to the client. Then client also should approve that yes, we require some hard disk, and then the people who are there, or the Unix admins, they are going to contact the vendor. So suppose that the server is from IBM, then the Unix team is going to contact IBM asking whether this model of hard disk is available in the stock or not. And if the hard disk is available, then again that information need to be passed on to client, and client need to get finance approval, and all those financial dealings and all should be ready. And once the payment was made to IBM, then IBM will do the shipment of the hard disk. So you have all this process involved in real time, and by this you can understand minimum to minimum this will take 20 to 30 days. So if you want a new hard disk for a server, assuming how fast you do it, it will take minimum of 2 weeks, that is 15 days. And suppose you want a hard disk very urgently, then it may not be possible to handle such situations. So that's the reason in real time what we will be doing is, instead of going and taking the last minute chances, we will be estimating the space in now itself, and that in that process we are calling it the process of doing it, we are calling it as capacity planning. So that is what you can see in the points. The first point says it is the process of estimating the space requirement for future data storage, and we will do this by collecting the free space information from all the table spaces, either in a daily basis or weekly basis or monthly basis. And third point says we need to observe the difference in the free space and should be able to analyze how much space is required in future, and how we are going to do that with the help of a select query, which was mentioned in point number 4. So let me go and run this command. So you can see here we have a view called db_free_space, and this is going to give you how much free space is there in each and every table space. So suppose here you observe that there is a table space called big TBS, and right now the free space is 50 MB, and when the data insertion is keep on going, then obviously this 50 MB will come down, or it will get reduced. So you need to take an average on a daily basis or weekly or monthly basis, and then accordingly you are going to do the estimation. So you can see in the fifth point, suppose if we observe that there is a table space called users, and for that table space daily 500 MB of the free space is getting reduced. That means for the next 1 month we would be requiring something like 500 MB into 30 days, that is totally of 15 GB. So if we observe like every day 500 MB is getting reduced, then the estimation that we concluded for 1 month is 15 GB. And sometimes in real time you may not do for only 1 month, you may do it for the next quarter, that means the next coming 3 months, or sometimes the next coming 6 months also. So after you do this estimation, what you are going to do? So the sixth point says that once we analyze the space that we require, we need to check the availability for the same in the mount point. For example, here I got the observation that 15 GB is required. Then I would be going and doing a df-h, and under this availability column I need to check whether that 15 GB is available or not. So assume under U01 I require 15 GB, and so we will be verifying whether 15 GB is available or not. So assume in our case it is 80 GB, so that means much space is there, so I don't require to order a new hard disk. But if at all you observe that here there is some less space than 15 GB, then immediately you would be placing an order for a new hard disk, or to get the space added to this particular mount point U01. So this is what you are going to do basically with capacity planning. And whatever the information that you are tracking, for example this one, so simply you can put this in a Excel sheet, and you can maintain that for record purpose. And how we are going to do this task, it depends on the database. Suppose if your database is very fastly operated one, I mean very dynamic one, then you need to take this free space information daily from the database. Or if your database is not that much dynamic, then you can go and do it weekly basis. And if your database is very much not updated with the data, then you can do it on a monthly basis. For example, in a banking sector, every day so many transactions will run and so much of data will be loaded and all. So definitely we need to do this on a daily basis. And if you have some other databases, then you can go for weekly or monthly basis. So this is what actually mean by capacity planning. So anybody is having any queries over this concept? Yes, Sanjay. Whenever we require some new hard disk or some space to be added to the mount points, then we need to contact Unix admins. Okay. So anybody is having any other queries? Okay. So let us go with the next concept, that is undo management. So undo table space, I will come to first 2 points later. So this will come to that later, but okay, second point we can go through that in a database only one undo table space will work at the point or at a point. So even though you can have multiple undo table spaces created, so but still out of all the created table spaces you can have only one up and running. So that is one point. So we have under table space management we have a very important concept called ORA-155 error. So basically Oracle database is having so many error numbers and error messages, and it is difficult even for us to remember each and every number and every error message, and even in interviews also nobody will expect that, but they will at least expect one particular error that is called as ORA-155 error or snapshot too old error. So we need to understand about what is this error, why it will occur, and what are the solutions. But well, before going for it, we need to go for some important points that we need to remember. So the first point says the undo blocks which are occupied by a transaction will become expired once the transaction is committed. And we know what is meant by undo table space and what it is going to store. So undo table space is used to store the old values whenever some transaction is getting modified. So if you are updating some data, whatever the old values you have, those old values will be stored in undo table space. Now suppose I have issued one update statement. So let me say I said update table T1, set salary equals to 10,000, where employee name equals to Mark. So now when I run this particular command, then what happens is before updating this salary to 10,000, already under this there will be a value, right? Already Mark will be having one some salary. So let's assume that is 5,000. So that 5,000 value will be stored in undo table space, and 10,000 value will be stored in that particular data block. We know how DML will process. Now that means currently the new value is there in the data block, and the old value is there in the undo block. Now if after issuing that update statement, if I set commit, then what happens? We know what is mean by commit. Whatever the statement that we issue, that will be made permanent. That means this salary was fixed to 10,000. So in such cases, whatever the old value 5,000 that I have stored in undo block is of no use now. The moment this update statement got committed, that particular undo value or that particular old value 5,000 is not having any value, is not having any reason to be there. Why? Because after commit you can never do rollback. You people already know that. So because after commit we don't have a concept of rollback, we don't require that 5,000 value now because the transaction is already committed. Now in this kind of situations, what Oracle will do is whatever the blocks that Oracle has use it for undo table space, it will make those blocks as expired blocks. So let me show you in an example that one. So I am creating one dummy table. So if at all you want to create some dummy table with multiple millions of those, then this is the best way to do that, because in our practice databases generally we don't find very big tables. So this is what usually the method I follow. So I have given a commit also. Now if you check the count of the table, so you can see it's containing 36 lakhs 70,016 records. So this is what this is how we can create some dummy table with more and more rows. So what I have did is from EMP table I have created one dummy table by the name T1. Then what I did is I start inserting the rows into T1 again by taking from the same table, that is T1. That means whatever this 14 rows that will come from the EMP table, I keep on inserting the same 14 rows again and all, and finally I achieve this particular figure. Yes, Sanjay, definitely every EMP table will have 14 rows by default. That's common. So now what I will do is I will run one update statement on this particular table T1, and what I will do is set salary equals to 10,000. So for all the employees in the table I am making the salary as 10,000, and before issuing that I am opening another window for us in order to understand about undo. So to understand about undo, we have a view called $undo stat. So here it is going to show you about active blocks, unexpired blocks and expired blocks. Or let us put in this way. Okay. So we have sorry, I need to use sum, I believe. Count, it is going to show you a different. Okay. So now you have active blocks. So what is mean the active blocks or active undo blocks means if any transaction is using some undo blocks, then the status will be active, and if the transaction completes, then the status will be unexpired, and if the transaction got committed, then the status will be expired. Now let me show you it here. Okay. Update T1. So the update statement is going on, and you would be observing that this values is going to change. So usually what Oracle will do is, whenever you have some expired blocks, first Oracle will try to use those expired blocks instead of creating a new blocks. So that's the reason here you are not seeing any change in the values. So Oracle active blocks, anyway Oracle can't use that, because as I said, active means currently Oracle is using those blocks. Unexpired means the blocks are there, but the status is unexpired. So even we can't use that unexpired blocks, and then we have expired blocks, which means no transaction is using them. So we can actually go and or Oracle can actually go and use those blocks. So basically Oracle is going to do that. We may need to see if Oracle will change something. Okay. So now if you look at earlier the values are like this: 24,640, 1,032 and 50,256. But now you can see active blocks count increased to 40,000. From 24,000 it got increased to 40,000, and unexpired also got increased from a lower value somewhere around 1,000 to 4,000 and all. So that means because this update statement is going on, some active blocks are getting generated. Now once this update statement completes, then if I give a commit, then more expired blocks will come into picture. So that is what basically the first point says here. Whenever undo blocks are which are occupied by the transaction, those undo blocks will become expired if the transaction got committed, because after commit we don't require that undo value anymore. So is this point clear for everyone? Okay, so that is one important point that we need to understand. And the second point we have is this is very simple. For example, let's say one of your friend is depositing some amount into a bank account or into your bank account, and at the same time you are selecting the account balance in ATM. So your friend has not yet deposited the money. Let's say the cashier is still doing the transaction. At the same time, you are checking the account balance in an ATM. So will you be seeing old data or new data? I mean, will you be seeing the old balance of your account or the new balance of account? Yes, definitely we would be looking at old balance, because as I said, the transaction was not yet committed. So if the transaction is committed, then you will be seeing a new balance, but because it was not committed, you will be seeing old balance. Now from where you will be seeing this old balance? Because when the transaction starts, that old value will go to undo table space, right? So that's the reason when you check your account balance from ATM, basically you are going to get the data from the undo table space, not from the data files. So that is what the second point is going to talk about. The data will be selected from undo table space if any DML operation is being performed on the table on which the select query is also fired. So if you issue a select query and a DML operation on a table, always the select query will get the data from the undo table space only. And this is why Oracle is going to follow this is just to maintain the read consistency. So these two are the important points to understand before we proceed for this ORA 1555 error. And is everybody clear with those 2 points? Because based on that only we can have we can have a look at ORA 1555 error. So if you have any questions, please ask me here itself. Okay, so let us go and understand about Aura 1555 error. So what is happening in Aura? I mean, I am taking a situation, for example, and from this situation we will identify, how that Aura 1555 will occur and all those things. So there are three transactions hitting the database, and assuming these three transactions hitting the database in fraction of seconds. So it's not like one transaction is appearing at one time and then after some minutes of gap second is appearing. It's not like that. Assume all the three are hitting the database within fraction of seconds, and in that case what happens? So the first transaction is the transaction 1, and what it is doing basically is this transaction 1 is updating a table called A, and after update the statement got committed. So you know very well, when it is doing the update, it will take the values from the undo table. It will store the old values in undo table space. So that is what will happen, and dirty blocks will be generated, and those dirty blocks will be there in the right list of database buffer cache. Assume these three blocks what you are seeing are dirty blocks, and these dirty blocks are not yet written to data files, and that is what represented with this cross mark. So dirty blocks are generated, but still those dirty blocks were not written to data files. They are still there in the database buffer cache. Now the reason why they are not written to the data files is checkpoint event didn't occur, and you know already that without checkpoint event DB writer will not write the data to dirty files. Data files. So that is what the point here is. And because the transaction, this particular transaction 1 got committed, whatever the undo values that are occupied, assuming this is my undo table space, whatever I highlighted. So this undo table space, whatever the values that undo table space is having for A, those blocks will be expired. Because just now we understood from the first point that whenever a transaction got committed, then undo blocks will be expired. So what happens is the undo blocks which were there in the first three blocks, and assume this the other space is already filled up. So let me put it like this. So assume all this space is already full. That undo table space is already full. Let's assume that way. So first three blocks, whatever we have, those three blocks are actually occupied by A. So when transaction 1 hits the database, this is the situation that you would be observing in the database. But the status of these three blocks which are there for A is expired. Why? Because commit occurred here. So then in a fraction of seconds of time, transaction 2 hit the database and it is updating table B. And there was no commit here. And because transaction 2 wants to update table B, it will come to undo table space. But in undo table space already this portion, whatever I have highlighted, this portion is already occupied. So the only available free blocks are these three, because they are expired, and Oracle whenever it is expired can reuse them. So what transaction will do, transaction 2 will do is, it will override the values of A to B, and that is what you are seeing in your class notes diagram. And because this was not committed, still that B is hanging over here. Then in another fraction of seconds of time, you have transaction 3 which is trying to select the data from A. Now this transaction 3 actually should see new data. Why? Because it is selecting the data from A, but A is already updated and committed also. So we know already that whenever the transaction is committed, then the other user should able to see new data. So here transaction 3 should frankly see new data. So to check the new data, this transaction 3 will come down to data files. But in data file, it would not be able to identify any new values. The reason is those new values were not yet written to data files, it was still there in the memory. So what transaction 3 would do is it will try to select the data from the data files, but it couldn't able to get new values because new values are not yet written. So then transaction 3 will assume that okay, if I cannot give any new data, at least let me give old data. So to get the old data of A, transaction 3 will come down to undo table space, but already those old values are replaced by B. So that means here transaction 3 cannot give new data from data files, neither it cannot give old data from the undo table space. So that means this particular select statement will not retrieve old data or neither new data. So in such situations, Oracle is going to throw one error, and that error we call it as Ora1555 error, and the error message is snapshot to old error. So the below 3 points are going to explain about those things. So just have a look at these 3 points and let me know if you have any queries. So just have a look at those things and I will be back. I am just getting a call. Just read those points and keep your questions ready. Okay, so anybody is having any queries? Okay, so let us look at the solutions of Vara 1555. I mean, how we can avoid this particular situation. So as I keep on saying that these transactions are hitting the database within hardly fraction of seconds time. So this problem could have been occurred. So usually this kind of situation you may not observe in real time. So that's the reason solutions, or I mean very frequently you may not observe this in real time, but how we can handle the situations. So we have some different solutions over here. So the first solution is you need to reissue the select statement whenever you are getting this ORA 1555 very rarely. Like once in a week or once in a month you are observing this error in alert log file, a user is complaining about this error, then you need to ask that particular user to reissue the select statement after some time. So because after some time, let's say if user is complaining about you know this particular error, you can ask that particular user to reissue the select statement after 5 minutes or 10 minutes or so, because in that 5 minutes or 10 minutes this new data, whatever the new blocks or dirty blocks are generated, so this new data might be returned to the data files because of checkpoint event. So this is the solution that you have whenever you are observing it very rarely. But let's say daily you are observing this particular error, then it will be better if you increase the undo table space size. So whatever the undo table space size you have, even if the size of that undo table space is very small, in such situation also you may land up with this particular error. So that's the reason increasing the undo table space size would be the solution. I will come back to the third solution, increasing this one. So the fourth solution is avoiding frequent commits. So here in this entire situation, the problem occurred because transaction 1 got committed. So if transaction 1 is not committed, then definitely this situation would not have arisen. So that's the reason if you if you avoid the frequent commits, then also this solution can be applied. And then from 10G onwards, we have a option called retention guarantee. So whenever you are using some update statement, so what you can do is, so suppose you are updating something like this, you can say retention guarantee. So if you use this keyword retention guarantee, what happens is, even though the transaction is committed, still that old values will be there in the undo table space. Retention means I want to keep it. Guarantee means mandatory. So whatever the old values are there, I want compulsory to be stored in the undo table space. That is the meaning of this retention guarantee clause. So this is one solution. But when we say retention guarantee, then till how much time Oracle will keep them in undo table space? Because as I said, retention guarantee means storing the values in old values in undo table space. But how long duration Oracle will do that? Oracle will do that for next 500 seconds, sorry, 900 seconds. And for that, we have a parameter called undo underscore retention. So undo underscore retention, the value is 900 seconds. When you convert into minutes, it will be 15 minutes. So whatever the old values that are there, so those old values will be stored in the undo table space compulsory for the next 15 minutes or for the next 900 seconds. So that is one option you have. And if you feel that you know this 900 seconds is not sufficient, then increasing this undo retention value is also a solution. That is what the third one is talking about. So these are the 5 solutions that we have for undo, this Vara 1555 error. And as I said, most of the times in real time you may not see this particular error very frequently. And there is a note below which says never you should allow a undo table space or a temp table space to be in auto extend on mode. So what is the complexity if you make that auto extend on? We will be discussing in tomorrow's class. And coming to the first point which we left out in undo management. So basically undo management is having 3 parameters in the database. The first one is undo management. So there is a parameter called undo underscore management, and by default you will be seeing the value as auto. That means Oracle will take care of managing the undo table space. Then the second parameter you have is undo underscore table space. So this is going to say which undo table space is active. So as I said earlier, you may have 10 undo table spaces created in the database, but out of 10 only 1 will be active. The rest of the 9 will be inactive. So which table space is active, that name will reflect here. And undo underscore retention is the third parameter, and just now as I said, this is the time duration to store old values in the database or undo table space. So these are the 3 parameters that we have for undo management. So this is about undo things, and tomorrow we will see the commands on how to create undo table space, then how to create temporary table space, all those things. So anybody is having any queries before we close the call? We cannot actually replicate Vara 1555 practically, Sanjay. That is what I said. You may need to have these transactions sitting in the database in fraction of seconds, which in practice we could not able to replicate it. So we can only understand the concept. That's it. Okay, so if nobody is having any queries, let us close the call for today here, and tomorrow we will continue with the rest of the concepts. So thank you everyone for joining the call, and have a nice time till tomorrow. Good night.